So good day, everyone. In the previous video, we have discussed about negation. So we refer to the negation of a proposition as a result of the operation of the negation operator. So essentially, we are taking the opposite na truth na value of a certain statement or proposition. So the negation operator is constructs a new operation from a single existing na operation. Okay, so for this video, we are going to introduce you to logical operators that are used to form new propositions from at least two na propositions. Okay, so these logical na operators are also called as connectives. So we will focus on conjunction in this video. Right, so let us proceed. So let P and Q be statements or propositions. So we have P and Q. So the conjunction of P and Q is the statement P and Q. So we have two statements P, Q that are being connected by the logical operator, a logical connective AND. Okay, and it is denoted by this symbolic na form P and Q. All right. So suppose we have two statements P and Q or propositions P and Q. So the conjunction P and Q will be true only if both of the propositions P and Q are true. Otherwise, P and Q is false. Okay, so that is the core of this conjunction. So P and Q will only be true if both of the statements are true. Okay, so consider the two statements. The integer 2 is even, and Q, on the other hand, 4 is less than 3. So we know that integer 2 is even, so the statement P is true. 4 is less than 3, on the other hand, is false. So the statement Q is false. So the conjunction of P and Q, namely P and Q, using this expressed in symbolic form, the integer 2 is even, and so we are using the connective and 4 is less than 3 will be false because the statement Q is false. So it will only be true, the P and Q will only be true if both of the statements are true. So this is the truth table of P and Q. So this table has a row for each of the four possible combinations of P and Q. If we only have only one variable, like variable P, the variable P can only have a truth value of true or false. So if we have another variable Q, right? So if the variable P is true, then the variable Q can either be true or false. So that's why we have TT and TF, okay? But if the variable P is false, the variable Q can also either be true or false. So we have FT or FF, okay? So we have mentioned earlier that if we are using the logical AND na connective, so we are taking the conjunction, so conjunction of two propositions, its truth value will only be true if both of the statements P and Q are true. Otherwise, it is false. So as you can see, P is true and Q is false. It is false. P is false, Q is true, P and Q will be false. And if both of the statements P and Q is false, P and Q is also false. Okay, so let us have more examples. So write each of the following statements in symbolic form and determine their truth value. So first, 1 is less than 2 and 2/3 is a rational number. So let's proceed. So we have the statement 1 is less than 2 and 2/3 is a rational number. So you can see that in this English statement, there is a logical and na connective. Okay, so we will take the two statements. So let P be 1 is less than 2 and Q be 2/3 is a rational number. Now, let us determine the truth values of each of these statements. So 1 is less than 2 is true. So it is true. And the statement Q, on the other hand, which is 2/3 is a rational number, is also true. So from our truth table, we know that if we are expressing this P and Q in this symbolic na form, we are using an and connective. This is a conjunction. So since both of the statements are true, so this will also, this conjunction will also result to true. Okay. Now, the second example, 3 is a prime number and 3 is greater than 4. So we have a logical and na connective, so meaning this is a conjunction. Okay, so we let us assume P to be 3 is a prime number and Q be 3 is greater than 4. So is 3 a prime number? Yes, it is true. 3 is a prime number, but 3 is not greater than 4. So Q will be false. So you can see that since this is a conjunction, this will result to false because Q is false. And in order for this to be true, both of the statements should be true. Okay, so P and Q is false. Now, let's have this another example. Let P and Q be the statements. P, 1 is an odd na integer, and Q, 1 is less than 2. So we will have I will show you some sentences in terms of sentences, and we will each of the sentence we will express it in terms of P, Q, and logical connective, and find the truth values of the given statement. So now we have 1 is an odd na integer and 1 is less than 2. So expressed in P and Q, so we let P be 1 is an odd na integer, which is this one, and 1 is less than 2, so that will be our Q. Okay, so and then we have a logical connective and, right? So we have the conjunction P and Q. So we know that P is true. So, and 1 is indeed an odd integer, and also 1 is less than 2. So both of the statements P and Q are true. So the conjunction will also be true. Now, for our next statement, 1 is not an odd integer. So what pattern do you see from here? So we have not. We have the word not an odd integer, meaning we set this as the negate. We are just taking the negation of P. So if P is 1 is an odd na integer, it's not P will be 1 is not an odd na integer. Okay, and we know that the P here will be is true, and we also let a Q be 1 is less than 2. All right, so we know that since we have it is connected by and, we use this symbol, right? So we have the not P will be false. Why? Because P, the statement P, 1 is an odd integer is true. If we take its negation, it will be false. Okay, so 1 is not an odd integer, not P, that will be false. Okay, and 1 is less than 2, so that is similarly just the Q, and that is true. 1 is indeed less than 2. So we can see here that one of our statements is false. Okay, so that means that the conjunction P and Q is also false. All right, now lastly, we have 1 is not an odd integer and 1 is not less than the 2. Okay, so we will express this in symbolic na form. So 1 is not an odd integer. So this statement is just a negation of P. Okay, this is just a negation of P. And 1 is not less than to 2. This is also just a negation of Q. So we will express this statement as not P and not Q. Okay, so taking the negation of P, this will be false. Taking the negation of Q, this will be false. So both of the statements are false. So the result of the conjunction P and Q will also be false. Okay, so for the next video, we will discuss about disjunction.